Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and execution strategies and I don't know what all. We're recorded. We show up on YouTube in a couple hours. I don't normally have a set agenda. Conversation goes where it goes. That's my leading spiel. Ryan and Jim were having a discussion about the execution strategy that Ryan is putting together that I only partially understand myself. And so we were mid-explanation when I hit the record button. All right, Ryan, let's try again. You have a graph. It drives the IR.
Well, no, it
Happens.
doesn't. So, so,
Okay.
so like the graph is just like, I don't know, like you have a question, right? I don't know. The question can be like, what's the IR for a function, or like, what's the size of a class, or like any question, right? And then it just you have an input that could be like the name of the class, or like its symbol, right? And then you have an output, which is like an object. Maybe that's like the IR or whatever. And then those nodes just get saved and cached, and they create a graph of dependencies that can be walked for like debugging purposes. Um, so like uh, the IR itself is more similar to like LLVM. It's almost SSA. It's not quite. It's I guess it's kind of similar to like Java in some ways. It's not quite stack based because locals have like fixed addresses. But you can think of it a little bit like that.
But it's control flow graph with basic blocks.
It has like a basic block, and then you have jump and branch. That's
Right.
basically it.
Okay, you have calls and returns into
Yeah,
function, start a function.
yeah. You can call or invoke specifically, and then you can also do return.
And is the graph being used to build? So I'm still trying to get the connection between the graph you're talking about and the IR you're talking about. Like if I parse simple or Java or C and I produce some sort of IR, a classical LLVM style CFG in basic blocks, you have another layer in there. You have this graph thing. Where does it fit in between parsing text and having an IR I'm going to throw to a Clang optimizer?
Okay, so the input to the compiler before this it goes into this graph, right, is the like source bundle, which is the files and their content. If
The
I
source
want to
code.
actually, yeah, if I want to parse that into an abstract syntax tree, that goes through the graph. Like everything in the compiler goes through the graph. And that's so there's a node in the graph um called like class AST or something like that. Let me see.
If something parses text, classical parser, recursive descent, or
Right.
LLR or whatever, you get a parser. And he
Yeah, so
produces out graph or AST.
so that would the parser would produce just an AST. So the graph would be the thing that runs the parser. So like okay, so I have a parse file, and then where do I call parse file? Okay, so there's
How does
module,
a graph run a parser? Because a parser has text and
right.
builds up his state from just reading the text, right?
So there's a type of node in the graph called module AST, and so you have to query the graph with uh the module AST node type with the name of the module, and then that spits out the AST of the module,
Okay,
and
so
that's a
so
graph
the
node.
in what other compilers I would have said was the some piece of the driver. The higher than the parser, there's a driver that says this is the compilation strategy. Here's my source codes. Here's my optimization. Outputs go there. Somewhere along the way, I stop and I call the parser to get an AST back and head to the next section of the compiler.
So like the entire driver is just the graph.
Okay.
Everything that the compiler does, except for like loading the source files, goes through the graph. And
Okay.
anything that I want is a graph node. So let's say that I want to compile the main function. Like this is the entry point to the compiler.
Yeah.
It's like, give me the IR of the main function. That's like the entry point to starting the compilation process,
Okay.
which is like, okay, well, So this enters the query type for give me the IR of a function, which is like, okay, I need the abstract syntax tree of the function to begin converting that to IR, right? And
Okay.
so that is like, okay, I need the abstract syntax tree of the thing that contains the function, the module or whatever, or maybe like a class that contains it or whatever, but like it's going to go through that recursively. And then those functions are going to create nodes, right? And so when I ask for like the IR of the function, or so the AST of the function, right? That is memoized. But that itself is going to depend on the module AST, which is also memoized. And that module AST is going to depend on the source text for the module,
So,
which
so
is the
you're
only.
using the graph with memoization thing as a way to structure the compiler driver. Like if I was to
Yeah,
look at compilers I've done of your, uh, there would always be some initial piece which was like parse the command line options, figure out what we're trying to do here. Then there's, oh, we needed to go get these files sucked in, and we ran a parser, and yeah, we got an AST back from that. But there wasn't multiple different files per se. It was usually one file at a time. And then you go from there, you take the AST and you go to some IR lowering and you go some optimization and IR lowering, some output. And but there was a more linear flow.
right. So it's completely. So there's only one like right now. It does have a little bit of that. Like when it loads the files initially and decides, okay, I'm going to grab all the files for the project and put them into a source bundle, and then the config files. And then after that, it does another step where it's like looking at the config and saying, okay, what's the main function for the target that I'm building? So it constructs the target configuration, and then it says, okay, what's the main function for that configuration? And then from that point onwards, it just queries that graph node and says, what's the IR of this function? And then it's not like everything else is just that graph.
I'm sorry, everything else is just what?
Everything from that point onwards, including parsing, lexing, sort of, and then like conversion to IR is going through that graph engine.
Okay. So you have more, you're not so linear as the things I've used in the past, which are just do one thing after another after another. They have a list and they're running
Right,
and
right. Like you can have one thread that's compiling something down to IR, and another thread is like taking a file and parsing it into an AST. Like they're completely separate, as long as they're like separate nodes. So it might be the same type of node, but it has a different like input, so it's a different node. So like you can have two different
okay.
module AST nodes. One of them could be finished, and then that's being used to compile some function, and another one's still being parsed. Those could
Yeah.
be running at the same
Okay.
time.
Okay. It makes more sense now. Like in simple, I just have a straight up, here's a list of phases one after another. If I were to go to the place of I need to be parallel, I'd have to restructure that. And in fact, it would probably turn into a DAG, a graph of some kind of things to do in whatever order.
Yeah, and one of the problems that can happen is that it may not be a DAG, right? It may be there may be a cycle, which has to be a compilation error. So it has to detect, okay, these six nodes make a loop, and then that
Yeah.
has to be an error.
In the FP error.
So
Yeah. Right. Okay. Yeah. I'm not that far down. That level of error detection, I'm actually, I'm probably going to hit that before too long now. Simple as getting to the point where he says, "Oh, this module needs that module. I need to go get it. Oh, that module's out of date. He needs to be compiled. He needs an input from this module, and that's my cycle. And then I have to detect and report."
yeah,
But
so one of the useful things of this graph structure is that any cycle is just detected as a graph loop. So I
yeah,
don't have to
yeah.
have any special logic for like, okay, these modules have a dependency on each other. It's
Well, you
really
have
the
it in
graph
one
node.
place. You have it in the graph that in the
Mhm.
over. Yeah.
So I can have complex dependencies between modules as long as they don't create dependencies in the graph nodes. Like, for example, I can have a class that contains a class from another module, and then that module can have a different class that contains a class from the other module. And as long as the classes don't create the dependency loop, it's fine.
Right.
Because even though the modules are depending on each other, the individual nodes are not creating a loop because like they're depending on like sub parts of the module, like a class in the module rather than the module
Right.
itself.
Yeah. That makes a lot more sense now.
Yeah.
I was seeing that coming last weekend when I was last doing things. I didn't actually get there, but
Yeah.
it's
So
coming for me too.
the transition from the existing resolver system to query graph is basically that, but query graph is it has a better debugging interface, and then it also has a different work, like it has a work stealing executor model, so it can run across many threads with like work stealing. So like kind of like the Go scheduler a little bit.
You've
And
you've
then
you've grabbed some parallelism at a high level, and
yeah.
I
And then
I'm sorry. So I keyed into I guess it's a while back. You were going into trying to unify and mementize whatever. And
MOI.
memoize, right. And the copy on right, cow. Um and sort of I've been into that since probably 15 years. Improving my own understandings of, internal dense memory. And I guess you've moved on past that. But,
yeah, yeah, that's still copy on write. Okay, so I think I misunderstood what you were talking about. Yeah, so copy on write is another structure that I have. Yeah, I do have a copy on write structure, and the idea here was like, okay, so I might create like a module AST object, right? And then that object may contain like subclasses. But if those classes are themselves copy on write objects, right, the module AST can be sharing memory with like the class AST objects because they're just copy on write objects. So they're actually like pointing to the same data. That was the idea. So like it lets them behave as values even though they're referencing some piece of data. Um, yeah. So yeah,
Piece
there's
of
also
data
a
that's
copy on.
mutable by somebody else. So
But
you're still talking modules and classes, and I would have said copy on write is something else.
well, it could be mutable, but it's a copy on write. So if you mutate it, you
Yeah,
get your own local copy, and then
right.
everyone else doesn't get to see your modifications. Like each copy on write object, like if you call the get method, it's going to return a reference to a potentially shared version. But if you call the edit method, it returns a mutable reference to a version that the copy on write object now has exclusive access to
Yeah,
because it copies it, and then
right.
um,
I think we know what copy on write is. It's just where are you using it?
So like I was thinking of putting it in like the AST in particular because like if I have a module AST, right, that contains like class ASTs that contain like subclasses. And so this
Uh,
is like a prime, in my opinion, a prime location for this like copy on write stuff.
yeah,
Because if
okay.
I have a memoiz node that's like what's the AST of this class, I don't want to be copying the actual content of like a class that has a bunch of subclasses in order to create that node. So I have this copy-on-write module potentially that is going to return a copy-on-write object.
Yeah.
Um,
It only makes sense though if you then also have a strategy or somebody has a point where they edit the thing. Somebody wants a copy that's not edited, so they just want the free copy, and somebody wants the version they're going to edit. And who's editing?
I don't think you would edit in this case, but it's generic enough that like it could make sense to edit them sometimes. I guess with like the module and AST specifically, it's probably mostly read only.
Yeah, I'm
okay, so I have two observations. Like, so I've gone with scanners and, forward scanners that, tokenize the line ending. And that line ending is, a 20K JSON, you know, body. And you just keep scanning it like CSV. It's not very much different. In fact, I have a CSV scanner built on the same JSON scanner. I posted that a couple weeks ago. Um, it's like a framework that lets you put an entire JSON serialization, deserialization, and JQ in 300 lines. So that works for me. And I'm not at the point where I'm looking at a new IR. Um, it makes more sense to me to just like um, internalize MLIR because I'm actually not typing all this in IntelliJ anymore. I use AIs, and there are a few shortcuts that come with domain knowledge of I want to go here, um, you know, far away and not, get carpal tunnel. Anyways, um, so that's where I've, wound up. Basically, like uh, before GPTs came out, we were doing models, um, with pandas, and pandas would just explode. Heap objects would be like 10x, 20x the input size. And so, I got it down to like,
But that's
uh,
pandas. That's because of the bad
well,
representation under the hood.
well, sure, I just got it down to like memmap mementos of location and, scanning forward at whatever Kotlin can do. Um, and at this point, there's nothing else Kotlin has to offer. It's just like it's time to like move this over to C++, put it into templates and see how far it you know
If you're
takes me.
scanning big CSV files, you should look at what I did with H2O because, you say Kotlin, but Java, JVM, and then I order of magnitude 10x faster than anyone else on the planet for the same shit.
I know. I look at your crazy, inline string view, right in the loop. You know, read it and throw it away. That's fast as fuck. Um,
But parse the CSVs into the same data structures is part of the deal. And then parallel distributed scale out parsing and compress and all that kind of shit. That's for dealing with CSVs or large 2D data sets. That's why
Yeah,
I heard you say there. If you're doing arbitrary random shit, like JSON that's completely irregular, it's not going to work.
my file parsing is not particularly efficient right now. I do skip lexing as a phase, which helps a little bit. I just parse from characters,
Yeah, I
but
skipped lexing too.
yeah, I don't
Waste of time.
understand. Yeah, I'm not a big fan of like separate lexing as a phase and allocating like because like that's a lot of memory allocations if you like make separate
Yeah.
allocations. So I
What
just
do-
don't do it. Like I do it kind of like as I'm going rather
Yes.
than
Yeah. And if you admit that you're lexing or parsing as you go and you need a lexer-like step, you don't need a lexer token back. You just need I got a number back because you already know you're getting a number, or I got a string back, or I got an ID back, or whatever. I don't need a token type because I know from context in the parser already what tokens is allowed there. Ah, yeah, this is 90% spam, but 10% of doctor. I got it. Sorry. Hello.
so I'm using like my JSON scanner
Hello.
as my lexer for C++2, CPP2,
Oh, yes.
because it's like an incomplete C++ that's got some latitude, so you can sort of extend it.
Yeah, take me
Um,
off your list and quit wasting your time.
and you can dog food on CPP2 baseline, and proceed with your experiments. Um, and instead, well, I am actually looking at the minimum hole that is required to dog food. Basically, it's fun stuff. But I hate ASTs. I actually wrote an EBNF combinator framework in the dense memory scanners that does the job fine, um, without picking up lint along the way. Um, so, I have a
What was
readable grammar that's
DBMF?
a
yeah. I've
EBNF,
extended
EBNF.
DNF.
Raucous Nor or something.
Yeah.
Yeah, yeah, EBNF. I know. I heard D, E. Yeah.
So combined, they are less than the size of a C++ 1700 line parser, recursive descent. And,
Everything has to be
it's
less than
about,
a C++ parser. That thing's just has to be a monster.
so yeah, the EBNF is about 400 lines and the combinators are a few hundred lines. And that gets the job done for memoizing shit to return to later, which, there's a whole other topic.
Yes.
I don't like backtracking. My compiler is like designed. I designed the syntax to
Yeah.
with hand like my parser is handwritten. And anytime I have thought, oh, I need to backtrack, I've been like, okay, can I just change the syntax so that I
Yeah.
don't need to backtrack?
Right.
And that's been working out great for me. And the
Yeah.
parser is relatively simple and like linear time. There are like some interesting algorithms that I've ended up with, like particularly around expression parsing. I have a linear time expression parser with operator precedence.
Yeah.
So I actually it's not linear, it's technically log linear because there's like a what's it called? Um I think
How do you get log linear? I
I
mean,
forget what
the standard, Red Dragon book was linear with operator precedence.
so there's a like an array of pointers to different precedence levels of like, okay, I have an object and here's a pointer to its left hand operand or whatever. And
Uh-huh.
so this each time you like encounter an operator, it's like, okay, this operator has precedence 5. So I can't remember if it sets all the values above or below 5 in the array, but like it takes whatever value is already there, it sticks this value like in that location, and then it updates all the pointers to like that were like less than or greater than that value,
Oh,
so
because
that
you're
the
building it.
next,
Well, it's not doing it. You're building an AST, right?
yeah.
Because the normal algorithm that I use is standard recursive. I say standard recursive descent for operator precedence. Looks one character ahead, sees you got an add, subtract, multiply, divide, decides precedence level, and either accepts or recurses again. That one is absolutely linear time, and it builds the tree in the parser's tracking as it goes without actually manifesting a tree object. And then you can output, for me, I output SSA, but you could just output an AST as you unwound.
Well, yeah, it's hard to do that because there's the operators could be like function calls or whatever because C++ style language. Let
Well,
me
but
see.
it'd still be you throw in a function call as a node and then carry on. That's
But it's still parsing. Like there's no semantic analysis that happens during parsing. That's one of the things that I wanted to make sure that doesn't happen because I want to be able to parse things in parallel across all
right.
the files, which I can't do if I'm
Yeah.
doing semantic analysis while parsing.
Right. So this has nothing to do with semantic analysis. It's just textually, I found a thing that I don't know if it's going to be a function call, whatever. It's an operator like Gizmo. I throw down, I record in the parser step and I recurse left, recurse right. I come back. I need to make a node. The node is an operator like thing. Now, is it going to be an operator overload with an inline and a function call, or is it a primitive add or whatever? I don't care at that point. Just going to record it and carry on. And then later, the semantic analysis will come through and say, this is an unsemantically optimized known add operator. And in fact, it's an add, or in fact, it's overloaded and I have to function call it or whatever the hell it's going to be. That's the later step.
Let me post an example of this in the doc. So the
Yeah.
reason it's log linear is because everything looks up this. Well,
I mean, I can
maybe it's
go
not
pull
log
up
linear.
the simple code for the same thing, but it's going to do the obvious thing. If token is plus, then go left and right, else multiply or reject, return, and it does a standard classic recursive descent.
Yeah, and then it's like I guess I could just post the whole function.
You're putting it
Uh,
in the doc.
yeah,
Let
why
me
not?
let me pull up the doc. Da, 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 da. I can't find my doc because I am completely
Let me just delete all these blank lines because
too many things running around at once. Here we go. Here is a doc. There's way too much code. Let me go share. We'll go stare.
I have a
Yeah, you got too much code. So you have
this is
operator map, and you're doing some lookup in here. Okay, so AA did a different thing where I had a map and I got it cheaply efficient, but that's a more complicated job. The thing that goes on in simple, which I should probably pull up here and throw down as a counterpose, um, is I have the operator list wired in, and then you can argue I don't want to wire in my operator list, and then you're fine. Simple. Where's the parser?
yeah. I could probably make this a more efficient, but it's got the right time
Gotcha.
complexity, which is the main thing, I guess. So
Okay.
like This is like checking for any binary operator and returning, I think, true if it finds one, and then false if it doesn't, I believe. So,
Here is,
Yeah, I just use like what looks like a boost parser in a different language to emit events and collect those elsewhere, which allows you to keep your immutable Pascal like code, um, and keep composing in pure space, and deal with the side effects on your user space code.
is there a way to force Java mode? There is somewhere. Anyhow, all I'm claiming here is the precedences are encoded in the function call. So the parse add calls parse multiply, checks for his adds or not, and if he's not, he's returning and you're done. And if he is, he built a node, an add or subtract. And in my case, he calls the other side and then he optimizes a little bit. But the real thing is the table is spread out in the code. Here you have a table where add and multiply if I find them. Yeah, here's your add and your multiply is floating around. Right there's your add and your multiply. And for me, those are broken out in the code. Now in AA, I did a table, but then I went ahead and implementation wise did a recursive descent where the parse add and the parse multiply would be the same, are in fact the same piece of code, but they take the token and they ask what his precedence is and compare it to whatever token he's currently at. So he has a precedence that he's at, and he grabs a precedence by looking up this in an array of plus character found you and says it's greater or lesser. So I'm either going to make a node or I'm going to go recursively down. Um, so it's still recursive since in AA, but it's done with a table lookup to get the precedence, and you get
so
in.
it's not really a recursive, it's more of a loop. So like it'll call this function once for each
Yeah,
operator token that it's trying to parse. So this is for the binary operators. There's another one for like other kinds of operators, but
yeah,
like it just calls it grabs a token and then it's like, okay. It goes to this
yeah. You got a loop.
operator bindings.
Yeah,
You see the operator bindings,
yeah.
and so it's gonna take the existing like expression, um, and then it's going to like apply it wherever the thing was. Yeah.
Well, I'd have to stare at see what you're actually doing, but the obvious thing is you're figuring out what precedence you're at, and you're restructuring your expression tree as you go. And for me, I'm building the expression tree by stopping and asking a question. First, I went multiply, which gave me something. And then I said, oh, if I'm a plus or a minus, I have an add or subtract. And if I'm none of the above, I broke out and I'm just done. I'm not an add at all. But now that I'm an add with an add or a sub, I go get the right-hand side and I've got a node, and then there's a little cleanup on the node, and then repeat because you can stack adds one after another. And so the decision about whether I go deeper or break out is done by looking at the token. And so it doesn't do a table lookup other than it just checks the next character. Is the character an add? Is the character subtract? And if not, you're done here. So it does mean that you go in and out of deep recursion uh, when you're looking at a random expression that he doesn't know yet. It might be a very trivial expression, but he starts at the highest, operator precedence level and says, "Are you a this?" And I say I have a parse add here and a multiply. I have like 10 levels there. Same as your 10 levels here. You have a bunch of eights, I see, but you have, 1, 2, 3, 5, 6, 7, 8. So you have at least 8 levels. And I have the similar count of levels. And I have to recurse in and recurse out for all of them. Now, is that more or less efficient? I think it makes no difference at the speed at which we're talking about. Oops, I lost the window again. Um, so this is just classic recursive descent for ease of understanding. AA, like I said, has a loop, has one body of this, except it has a precedence level as an argument, and it calls itself recursively with the precedence levels and does the table lookup. So you can have an arbitrary table of operators and add and subtract new operators and add them in the precedences, and the compiler will just pick it up. Um, but the implementation gets a little more subtle because it's not the add level, oops, goes to the part multiply level, goes to the whatever square root level or the whatever level, shift levels.
Yeah, so
Right.
this
Yeah,
I
go ahead,
actually
Matt.
don't understand it. Like is yours still linear time doing that, or
Yeah,
how does it?
yeah. Well, this is like classic Dragon book. So the assumption here is that I'm going to uh, go in. Yeah, no, it's constant. Yeah, it's linear. That you get constant factors according to how much you have to go in and out, but those are all constant factors. Eventually, I grab a character and I probe it a few times, looking for are you an add, subtract, multiply, divide. The
So
only
like
faster
I
thing people go is the LR style parsers where you invert the table. I'm going to say LL or LR. It's one of the backwards parsers, which are a bitch to write. So you grab a tool, you grab a Bison or a Yak tool, and then they get to load the character and compare it exactly once. This one is just going to load a character once. I mean, I'm assuming the optimizer cleans that up. So he loads
like
that.
like let's say I have an expression like this. How would you like
Then go
assuming
find your
like
expression. Where are you putting your expression? Further down?
chat? I put it in the Zoom chat.
Wow. Throw it in the doc. Let me find the chat. Chat I've closed.
Okay, someone put
Right.
it in the doc.
Yeah. So what does A plus B equals? Why
This
is
is like that's an assignment. I know that's not normal, probably
go to
semantically
the
invalid.
normalest go to the normalest possible assignment.
Well, I just wanted something that had a high level of
Yeah. So just say
precedence
A
there.
equals. Can I edit here? Is
Sure.
that
Oh, you killed Prologue.
no? Thank you. I, I'm not doing prologue.
I wanted I wanted something that was like a high level of precedence. So on this front, so like maybe do
I
equals
mean,
equals instead of
you've got three levels of precedence here.
okay. Let me okay, how about A plus B equals this.
Oh, you
There
got
we
an
go.
assignment. Okay, so you had a fourth level of precedence. So
Yeah.
this one is an assignment in the middle, which is fine. Okay. So then the parser says, grab an A. Somebody looked up an A. That's my left-hand side for your parse multiply up right above here, for instance, or parse add above that. Then he says, I came out of the multiply, which came out of unary, which came out of blah blah blah. Somebody parsed up an A, looked up an A, return, 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 return. I come up to the multiply and I say and add, and I'm looking at this plus right here next. I've done the A, I'm looking at this plus. I fail the match, I fail the match, I break out, I come up to here and I say the multiply was just the A value. And then I say, do a plus. Oh, yes, I need an add node, but I don't know what the other side is. That's my null. My left-hand side is an A, my right-hand side is not known yet. So parse multiply. Go back down in here. Card parse unary, parse layers down. Somebody bottoms out at id lookup says a B. Unwind, 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 unwind. The thing after the B is not a multiply or a divide. So unwind. He comes back up here and he's going to say, I got you a B. I'm done with A plus, and I return that at a higher level. Somebody not here, wherever the precedence for equals equals is, says, I found an equals equals, and you recurse down again and back up. So the amount of work you do for each token is some level of in and out, but that's a constant amount because I have a fixed operator table with fixed count of levels, and it's only equal to the number of levels in my table. So I have
Okay.
a factor 8 constant factor for each lookup as he goes in and out.
Okay.
So it's
Interesting.
linear, and maybe you're linear in the same way. I don't know. It looks like to me like you're editing your AST. Here I don't build unless I know where the precedence is. And then at that point, there's no more re-editing. I do I do partially set myself up here. I go ahead and make the half node with missing the other side until I get the other side done. But at the time I make that node, I know for sure it is time for an add. I just don't know what the other half of the expression is.
Right. So it's like constructing it like partially. So it's like everything like at each point it has the abstract syntax tree up to
Yeah.
the token that's been parsed, and then
Yeah.
it's like, okay, it's keeping track of the like insertion points that would exist for different precedence levels,
Yeah.
and then it just adjusts, okay, what
Th-
would the
th-
new
This
insertion point be?
this, by the way, is like classic Red Dragon book, like that 40-year-old book, maybe it's 30 years old, Red Dragon book. This is like very classic. I am just completely doing a tutorial on shit that was, taught in grad school 30 years ago. I assume it's taught in compilers today somewhere. Somebody has to teach some level of parsing. And if they have to teach it, I hope they teach recursive descent. But
I
that,
like this one better. I think this looks more efficient to me because I'm only doing like once I like obviously this map is not super efficient to like figure out what the
yeah.
precedence of the operator is, but you could change that to be more efficient.
Th- this
Um,
this is known. I've done it very bulky and large, effusively to see it for a tutorial. But no, these things are like stupidly fast. The constant factors on them are all tiny.
yeah,
That's
but still like just having a number, just being like, okay, this is at position 8, and then setting like
no, no, no.
6 pointers.
The table is a nice way when you're exploring a language design. Like I said, for AA, I have a table. And I don't do the table the way you're doing your table operators. The AA table mechanism is still recursive descent, but I've put it in these other places. But the table is there, and the table is there for the same reason. It's easy to go hack the table.
Yeah, so it is.
So it's a different design point for different reasons. I'm still trying to figure out why you need to copy or for loop and set things up here. You are copying, yeah, you're copying linear in the size of your table for each lookup, I'm assuming, or each time you're doing a token.
I think this could actually be a move, but
You might be able to restructure yourself and get rid of it, and then I claim
is
you're
there
the
shouldn't be
same.
any copies though. This should just be like, okay,
Why are you reassigning the operator bindings? Is this just a one-shot table setup here? This is not per lookup. I go, no, it is. You have a peak symbol. You're trying to look, okay. I'm getting confused by C++ syntax for having the embedded map and then the code afterwards, but that's a static. So yeah,
yeah,
fine.
there might be
This
a
is still.
copy here. I'm not sure. It shouldn't be. Let's see. Let me think. New
Oh yeah,
expression. Wait.
let's not diagnose that one. If you don't intend for a copy and you have one, then you do, and you have a
Oh,
bug, and
it's
you fix it.
trivial. Okay, I just see it.
Yeah,
It's not a big
yeah,
deal.
you have a bug, you fix it, and life goes on. Yeah,
New
fine.
expression.
No, it's a
This is
different.
binary.
The question for me was a different style of things, and one of them was that for loop looks suspicious. I don't know why it's there, but having a table was very nice. Hey, John. Yeah, nice to see you. Keep on parsing the free world. Exactly. And then what can you do with a table that you can easily hack the table and also have an efficient parser? The AA version is one instance of this instead of 10, and it takes an argument instead of having the 10th depth one be the nth precedence level. Um, so it's a little different layout, but same constant time. Um, this was because we grew out of doing the tutorial starts out with, return a 5, and then it was return 3 plus 5 or whatever, return A plus B, and you had to have a parse of an add. And then we did a multiply, and then because they're stacked, you got operator precedence, and then you got 10 levels. Well, you get precedence, so you get 10 levels of parsing. Fine. Very classic layout. Okay.
10 levels of operator precedence seems like a lot.
Well, he's got 8, and I know like C++ is like 15. Java's 15 or
Well,
16.
there's 9 because that starts at 0. But
0, 9. Yeah, I have a bunch. I have at least that many in AA as well. I think that's totally reasonable. So you got your logics, you got your compares, and you have div separate from multiply. That's weird. Add and div and multiply. Exponentiation, which is another weird one because no one ever writes exponentiation code, but they do, but it's really rare. You have some bitwise operators that are, this is one, this is logical versus bitwise. That makes sense.
And
And
this is
already
actual
you're, yeah,
exponentiation, not XOR.
Yeah, that's
Okay.
exponentiation.
Yeah.
XOR would be hash.
Oh, you don't have shift in there.
There is
Let's see here. I have very
hash
similar to
plus plus, hash
Java.
minus minus. I could talk about my decision to call it shift up and shift down if you want.
Oh yeah. I mean, I'm
You just
trying
don't
to
like left
on
and right?
purpose
Well,
be extremely close to what other people have done, other language C Java have done.
yeah, so I thought um so people get confused by shifts if they're new to programming because like what is left, what is right, which endian are we in? And then if you're
Okay.
like, okay, I
Yeah.
am representing bits left to right or right to left, and it's like, okay, people are like, okay, let's do this big endian thing, but then okay, you want to talk about things that are little endian encoded, and it's like so it's like bit 7, 6, 5, 4, 3, 2, 1, 0, and then the next bit after that, because it's the next byte is like bit, 15, 14. So it gets confusing, like
And
when you're working with little endian and trying to like.
oop,
So I'm just
you're
like, it goes
flipping
up.
between Indian and this. Yes.
Yeah.
Yeah, yeah, yeah. This is all good things. And I just counted here and I have 9 layers, 9 precedence layers. But one of them is complicated because I allow my comparison operators to be stacked all in a row. That is to say, way down here, I allow uh, something like min is less than or equal to x is less than max. So this lookup is essentially puts x into a temp. So call it x here, but make let's call it some random function call. I put the output of that into a temp and then use it again, and I have to have a funny loop so it looks. In the implementation, there's a more complicated game going on. But if I go count, I got like 10 layers, 9 layers, depending on which one you want to
So
count.
my assumption is that that expands into min less than func and func less than max.
Yeah, yeah, yeah. So that yes.
So no matter where you put the parentheses, you've changed the meaning.
I'm sorry. It's this. Does that make sense?
Yeah, okay. That's what I expected.
Yeah, yeah. So it's the semantic meaning of execute it once and then two compares. And then of course they stack up as many times as you like. And they can be equals and less thans, but you can't mix less and graters in a line. You have to all be less thans or equals. You can also do it with equal equals, but not unequals.
Can I put any function that returns a Boolean in that operator spot?
Yeah, including, you mean in the function spot in the middle? It's not the operator spot. You mean this function here?
Where you have the less than or less than equal to.
Here? In the
Yeah.
land of AA, I have this as operators, and then yeah, it'd just be any operator there. I mean,
Okay.
any less than or equal operator that produces a compatible result. Be careful here in AA because the operators are just normal function calls, and they always apply if the left-hand side admits to having the operator who takes as an argument the right-hand side. So I don't know what this does chaining for AA. I'd have to go make sure that it makes sense. In simple, this is going to be either the less than here is going to be comparing ints or floats, some integer type or some float type. So as long as they're all compatible on ints or all compatible on floats, it's all good. AA, this could be like matrices. For whatever I'm defining, I have a query weird lookup thing. I have a matrix multiply or matrix less than or whatever strange behaviors you want there. And as long as that lives and then this lives, I can do that in AA. That would be okay. Uh, yeah. And then the parser would have an extra rule that said, if you look like a less than operator and you have a series of them in a row and they're all compatibly less thans, you don't mix your graders in there, then that's okay. And he'll just, throw the results into temps and then line up the and operator to do he'll do this is just syntax sugar for this guy. So yeah, you could do that with arbitrary operators.
I've been thinking about whether I should do this or not on my language. I haven't really thought about the double like
Yeah, the double
combination of
thing, right?
comparison.
It's just syntax sugar, and it's kind of nice in a bunch of places when I'm just doing junk coding. Like think of what you're doing in your life when you're actually coding, not writing a compiler for coding, but you're actually coding something somewhere. How many times do you end up saying, I have to do a range check. It has two ends to it. And you write the expanded version by hand. You write this version. Right, and you repeat the dude in the middle. Now, usually for me, the dude in the middle is actually a variable x, and so it's actually a little cleaner. And I get min is less than or equal to x, and then x is less than max. So that's not terribly unclean. And if I have these like inverted and backwards, and I notice I'm making a range check, I will rearrange them like this so the x's are in the middle near each other, because I like it makes it more clear in my head that that visually pattern is a range check. That's a bounded two sides. The number of three or more in a row is extremely rare, but it's very, when you have it and you want to do it, it's very obvious. It's very telling. It makes it very clear you're doing these things are ordered. I'm doing a quick sort and the min bound and the pivot point and the max bound and the range on the
Yeah.
very end, the limit of this and that. They're all in an
I've
order.
written lower bound is less than A is less than B is less than max.
Yeah, right, right. Zero less than min, less than x, less than max, less than, ray length or whatever. Yes, you get a very obvious, this is an invariant that is being held here.
I don't think I've ever done
So,
more than four,
oh, I don't think I've done more than four either. I was trying desperately to come up with like a
but
secret
I've done
thing
three
I
a
did.
lot, and I've done four sometimes.
Yeah, right. It's not common, but it's not hard to do in the parser, and it's just a little syntax sugar. So maybe, it's what you call cherry picking. Small pain, small gain.
Yeah, but the one thing that creates a little bit of an issue for me is like if I have okay, so if I have like A less than B less than C, right? So I now have to decide like when I'm parsing A less than B, do I store this or do I like have to match ahead of time this like okay,
Yes.
A,
Right. I
there's
match ahead of time. I do A less than B. Now I look, do you have the next operator that is compatible? So I already got a less than, so I know I can only accept a less or less equals. As the or double equals. I can't get double equals. So I look for those next tokens, and if I find them, I do special, and if I don't find them, you're done. You move on. Like, but it is another look ahead in the middle of that guy. And that's done for me in my, you have a parse multiply and a parse add. Well, I have a parse, comparator, and he has a special thing that says, okay, I found one of these range checky guys. See if there's a compatible follow on, and then do a for loop and capture all the pieces parts right now, and do the for loop for the next guy, and he's already here
so
waiting.
my thought here is like the confusing part here is going to be like if the overload can potentially accept a value instead of a const reference. Maybe you don't have that in simple,
I
but
don't,
like
yeah, I only have values. There's no const references would be values that get folded up at compile time that happen to be all constants and they collapse. But I don't have a special guy which says this is a const ref. So things like the min or the A or the B, they just parse as go find an id in scope, right? You go recursively descent, you get down to the id lookup. It's the same precedence as looking up the number five or the null or a constant, a bare constant true false. Look up an id. Okay.
so like do I decay this to like okay, I have A less than like a const reference to the B, and then it's like okay, and then
Yeah, it's
the
a, saying I
junk
don't have a
reference
difference between const reference and not the const
B
reference, so I don't have that
is
problem.
less than C. Like I could decay it into like this.
Yeah, move it into the doc. I know you're putting here, but we just got more code blocks. Just plot in the doc. So the problem is the chat disappears, and future watchers of the video don't get to see the things here. Like, don't put your entire wad of code here. That's too much. No one's going to read it. This thing you have in the middle here. But then down at the bottom, you've got, yeah, right. You're trying to come up with, do you have two different parsing points for the two different flavors of different places your code where you look for const expers or not? So assume B is an arbitrary expression. It computes some interesting complicated thing. It's a function call. You have to save its result and use that result for the next comparison. And then as a temporary object lifetime, it's done. So you have lifetime management issues in in C++ that simple doesn't have.
Okay. I have to go for like 30 minutes, but I'll be back.
Okay.
Sorry, yeah. All right,
And if
yeah,
I
I
put
put
an
in about 100
exclamation point
lines.
in front of the A,
I'm sorry. So too many people talked at once. So Aaron, you had something short. Then Jim was going to say something.
yeah, I said if I put an exclamation point in front of the A, what just happened?
Oh, way up here. We're gonna have to come around to Jim. Like one of these here?
Yeah,
Oh, that's it's operator
like
precedence. If bang binds tighter, and
I
it probably
assume
does, and I
bang
need to look.
binds more than equals
Equals.
or
Yeah.
less than.
Yeah, if bang binds tighter, and I think it does, then the bang will wrap around the A, and then that will become as if you had parens. Oops, somebody's typing at the same time. I can't see my fingers. You would end up being like this.
Okay, because having an operator in the middle of a chain of comparisons that has a lower binding affinity than the comparisons is going to end the chain and be confusing and hard to read.
Yeah, in the chain. Yeah, and now you want parens, right? So you could also put the
Yeah,
bang here. It's all fine. Um, but if I had something that was a
a lower binding precedent.
yeah, I'm trying to think what's a lower binding one here.
I think ampersand, ampersand, the logics were less than your comparisons, weren't they?
There probably are, and there probably are for on purpose. Well, you can't do this. That's just not, you're missing a value there. Now
Yeah,
you can
that's
do
true. That's just a
this.
syntax error.
There's an obvious paren wrapping that you're going to go to that all makes sense.
Yeah, okay, that makes sense. As
So
long as the person
you
vaguely understands the
the semantics here.
right. So if that becomes and then on the other side of the C you say equals equals D.
Like you mean like this?
And between B and C.
Yeah, this is a classic. Operator precedence equals
Yeah, and it's
binds
just
tighter.
operator
So
precedence.
so it's
You're comparing the first ones, you're comparing the second ones, and if what you actually mean is all of them in a chain, then put in the parentheses and you're fine.
yeah, right.
Okay. Yeah, that's actually less confusing than I was afraid it would be.
Yeah, okay. I mean, Cameron and I went over this a while ago. I don't know, he came up with it or I came up with it. We together came up with it. I think maybe he actually came up with it first. And but we were like looking at it, it's like this is really easy to do. And gosh, it does make certain expressions a hell of a lot easier to understand. So
I mean, it does
lucky
exist in
this.
other languages.
I'm sorry?
The operator chaining like that does exist in other
Does
languages.
it? I haven't I can totally believe it because it's an obvious thing, but I haven't used
I
it
don't
in
know,
other
pull up
languages.
a Python terminal and say
Oh
one less
God.
than two, less than three.
There you go, Python. That would be the obvious one. Do I have Python lying around? No.
You don't have
Python. Oh, I
Python
have a
installed?
Python 3. What? One less than two, less than three. What's he good? True. Okay, but that doesn't help me any.
Not seeing that in a screen share.
No, right, because I didn't have to break the window over here.
Ah, okay.
Because I'm grabbing it off of my work window, which has stuff that maybe no one cares, and I could do it in my work window and no one would care. But I was trying to type one less than two, less than three, but I don't know what Python intends here. Like I can do greater than here, I think. One more, and then I'm going
Well,
to share screen anyhow.
I was
Yeah,
gonna
okay,
say if you
fine.
put parentheses between the one and the two, then you should see
Yeah,
if the behavior changes.
let me attempt to share screen Python here. Stop, share this window. Never mind all the other windows. So here I am in a Python window. One less than two, less than three. Okay, what was the right? So whatever he's doing there, I don't know what his semantics are. Yeah, one less than two returns true. True is less than three. Is that what's
Can
going
you
on?
execute that?
Yeah, because he's Python, and so he'll say it's not as bad as JavaScript, but he'll say yes. You can mix Booleans and ints, and at
Okay,
least in
so
simple and
three
AA,
less
Booleans are
than two
just
less
ints.
than one is a better test.
Do it. Say it again.
I said three greater than two greater than one would be a better test.
Okay, and now
Or
where
just
where
putting the
should I
parentheses
wrap to
on the other
cause
side.
see?
If I'm
So
not
so
mistaken, that is the feature that Grok would keep from Python is, continuing a protocol.
Oh.
Um, anyways,
Yeah, so I think this guy here reports back as true, and true is not greater than one.
Cliff, can you run the line that I just dropped in chat?
Da. Oh God, the second one?
The second one. I forgot the Python capitalizes the Booleans.
Yeah, well, I don't know what the hell I'm doing here. Now you're trying to assign to
Oh,
false.
sorry, 2 equals.
Oh. Okay, false
Okay, so it's
to true.
definitely doing the
What?
precedence because for false to
Oh,
equal false, that's true, and false is in the list false, which is true,
I'm sorry. If the precedence was this guy first, that's true.
right?
And then
But false is
false
not equal
equals,
to true.
yeah. I mean, if the precedence is this, right? Not. Okay, so now is the precedence this? Right, it's not. So what the hell is it? I'm
It's
confused.
exactly what you were just proposing. It does the first one, and then it does the second one, and if the ANDing of the 2 tests are true, then it's true.
Oh, it's sharing the false in the middle. So he's saying it's
This
this,
is my test that is forcing us to determine whether it's using your behavior.
this.
Yeah,
Except I
except
if you
it's the
can't do
word and because
Python,
it's
I can't do
Python.
Python either. Oh my
Yeah, so it's
God.
true. So yes, that is the exact behavior we're seeing in Python as tested by the false equals falsing
Oh
false.
God. No,
I thought that was a good test to
it's
force
a
it to
great
disambiguate.
test. I disagree with the language design, but then I'm not a Python guy, so that's not
But you were
not
just
my issue.
proposing this exact behavior
No,
for
no,
if
no, no.
I'm
I
chaining
was
together
limiting
operators.
limiting you to less than, greater than, equals, not to the in syntax.
But
That
it's an
was not what I
operator that
was
returns a
allowing.
Boolean. It's subject to chaining.
Wow. It doesn't match my eye. This is the original expression we wrote. It doesn't tag in my eye as a valid, sensible thing to write. And maybe it would in a Pythonista. Not for me. And it's doing the chaining that I was asking for. So maybe that's
Yeah, it's
correct.
doing the
Maybe.
chaining that you are asking for.
Yeah, okay. Somebody else is in chat now doing some giant thing. Let me go find give me my stretch window. It's Matt,
But I do
chaining
like this
operations
piece
for
of
Python
code to
and
find
chaining
something that no
comparators.
matter where you put the parentheses, it behaves differently.
So Matt, are these what language is this? Is this a proposal for something?
Someone proposed this for C++. Actually, several
Oh,
people.
yeah. Okay. All right. So it's not yet, but proposed. Right. Let me share again. Maybe this is the correct one.
It does actually have comparison with Python, which does this differently. If you scroll down, so first of all, this example shows what would be the rewrite, right? This would be rewritten as the provide the compiler as if you have it on top of the screen.
Oh, I see. I see.
But this if
Yes. If yes, this is what I'm doing now.
it,
I do this and I get this.
and then scroll down until you see Python header, and you will see that Python actually does it differently because the
Oh, geez.
sentence is different in Python. So it's actually a little bit screwy.
Right. So okay. Where is he
You can
differently?
actually have x less than y greater than z in Python, which is interesting.
Where you got a
It's
mix?
just on top of the citation, yeah. Because
Oh,
the
I disallow
is
this.
different in Python than in C or C++.
Okay.
So
Yeah.
there are differences here.
I say that is no good. So they're saying it's legal but not pretty, and I just say no. Huh. And and then this, uh, and it's not this. Right. I am taking this as a chain. B is greater than A, C is equal to B, D is greater than C, which is not this. You need parens to get that. And of course, this is just like, yeah, they say, and then not likely the meaningless this. This is very much meaningless. Um, yeah, okay. Yeah, so maybe it'll happen to C++ too. Whatever steam engine. When it's steam engines, it's time to steam engine and steam engines. Fine. Not that this is that magnitude. Oh, here we go. Yes, a few thousand instances. Yes, this one's a common one. And right. They should get their spacing fixed in their document and just rewrite it that way. Zero less than index less than max less than equal index. This is like the canonical poster child. Um, and for floats, it would be 1 to 0.
I
Yep.
definitely had switch statements that were, or case statements that are easier to read if you are
Case statements. I'm afraid
more
that,
switch statements where you're just going through the, is it in this range? Is it in this range? Is it in this range?
yeah. Um, if you have a bunch of ranges you're choosing from, I'd stare at a switch. There's always one of these things where it's worth it in my head to spend a little time in the expression of the code you're writing to get it more clear, even if there's multiple ways to go do it. Here's somebody doing this. Almost always, if somebody's writing this code and it's passing the compiler, they have a bug. They accidentally wrote a bug and the compiler did not help them find it. Fine, cool. All right. Oh, wait. Jim, what were you doing here? It's just like your version of the same thing. You have an operator precedence table and you're trying to figure out how to do it. Are you online, Jim? You're muted. You failed.
Talking in mute as usual.
Okay.
Sure. Yeah. So, yeah, I've done a lot of spirit parsers over the years, and this is just OpenAI make me a spirit parser, and instead of a swing window or a freaking Node.js front page, it's a spirit parser for the grammar that I had on hand. Um, Instead of a regex that Herb Sutter put into CPP2. So he wrote a transpiler in straight regex for CPP2 to C++, um, which has some downsides. And a lot of people told him about that. So, anyways, um, but it works. It's a reference transpiler. So you can use that to make, your own abstractly, specialized version of CPP2 with a reference and, loss and similarities and so forth.
Okay,
So,
wait, back up for a second. That's the third time you said
okay.
CPP2.
Yep.
Is that C++, C,
That is
or I don't know what it is?
that is TypeScript for C++. According, yeah, that's Herb's own, goal. That's a
Oh my God.
definition. So
Can we
you
shoot
have
her
something
now?
that you have something that looks like TypeScript, and you have a shitload of languages that look like TypeScript. Um, and so it transpiles to C++. Um, give or take, there's a pure syntax and a mixed up syntax and a lot of,
I mean, everything
anomalies.
transpiles to everything eventually, but not usefully.
Well, their
Fine.
distance is very short. So, like,
Okay.
everybody wants that UML style, except Java.
What's the UML style?
With a colon with the type after
Oh, colon's the type
the
after.
declaration. Yeah.
I
So,
like it, actually. You're right. You're right. I mean, I'm used to the Java version type first, but I kind of like the colon type after. Fine.
Mostly I like colon and then the type after because it's easy to leave off.
Yeah.
The
Yeah.
number of times in a C++ style you have to use the word auto. And it's like, I don't want to read the word auto. If I want to not specify a type, it should just not be there.
That's correct. You should just move on. Yes. Simple is forcing you to have a type variable there as well. Instead of auto, it's var. 3 letters instead of 4, but yeah, same. And that's just as a Java and C history. I wouldn't have otherwise done it that way. AA has it afterwards. All right.
Frequently in JavaScript, you have to have that pointless annotation simply because they got the defaults wrong on variables being local by default versus global by default.
Oh
That you
no.
often have to say var just to make it appear in the local scope.
Interesting. Okay.
Well, so this is for me, you know, I can I can route this. I can put a sea of nodes, front IR, in front of MLIR on top of CPP2's output or grammar, and you guys can, yeah, do the crazy stuff, um, and start to specify features of a language. Um, I mean, so yeah, C++ is not the prettiest thing, but
What happens
the
in your language if I have an uninitialized left-hand side?
um, there's a whole lot of safety built into C++ too. The only thing it doesn't have is a borrow checker. I thought, well, shit, let me just add one with sea of nodes. So um, I I couldn't quote it to you. I mean, it's not that important to me. It just Rust really annoys me. So
Oh,
um,
yeah, Rust.
so this is my side, whatever background experiment. Hit enter every few hours and come back to it. Um, it's been rebooted about 3 or 4 times because these LLMs like to take the CPP4 front from Herb Sutter and insert it instead of the compiled prototype and claim 100 on the regression tests. And that has happened more times than I can count. That, oh, we're
Well,
using we're using the transpiler to compare to your output. Well, let's just substitute the transpiler on both sides. We win.
yes.
So
Let's say there's your problem.
that has happened so many times. So I could get out C Lion and do my, vertical columns and cut and paste and make these things. But it's laborious. So uh, that's my status for my language. Um, and to my knowledge, you don't get to do as many C++ type inference abuse features. And really, my main interest is a better compiler than Kotlin native. So I'm sorry, I couldn't tell you, Aaron.
We'll figure it out when it's not when you've had time to think about it. Aren't you like in New Zealand? Isn't it like 3 in the morning or something?
No, I've come back, but
Oh,
Central Time now.
no. Well, geez. That's like right next door.
2 3 hours.
Yeah. There's hardly any distance at all. All right. Are we beaten to death parsers and operator precedence today?
I wish Ryan was here because it sounds like what he's doing is a whole lot of pain for stuff that seems like
He,
he could.
he's on a journey of discovery.
I think so.
Yeah. Yeah.
Speaking of parsers, my parser generator had a big step this week.
Yeah.
It can parse ambiguous statements, so it can do. It can identify the difference between a tuple declaration and a lambda declaration. Delay its identification until it reaches the arrow.
The arrow, yeah.
So that's really
Yeah.
good.
Okay. Yeah, so I do the same thing.
Yeah.
I got
Yeah.
open. I got a variable. Huh. Wonder what's next. I got another variable. Huh. Wonder what's next. I got another. I found an arrow. It must be a function header. Oh, I didn't find an arrow. It must be a list. And I just gather them little id tokens until I find the distinguisher. Yeah. Yep. It makes a messy spot in the parser for sure.
Yeah, but it's part of the generator, so you just give it the syntax
Ah, you're
and it
yeah,
just
actually generate. Yeah.
I'm actually creating a parser generator
Yeah.
that does
Yes.
this
Okay.
using
Okay.
LR parser, so it's working really really well.
Nice. Okay. Why are you writing a parser generator, especially an LR parser generator? Isn't this like old school? Like, hasn't this
I'm
been
right
done for 40 years? What's going on?
because I'm sick and tired of having to go back through my parsers to add in new language features and stuff. So if I can just edit the syntax, run
Okay.
it, and actually get to the fun stuff, which is dealing with the new language constructs, not having to go through and go, now I've got this ambiguous statement that wasn't ambiguous before because they've changed something. Let's go through and basically rewrite the parser because you've got to every freaking time.
Wait,
Okay.
what?
Are you doing this in C++? I'm curious why not Spirit? I mean, that's my own, you know, experience, but um, yeah,
I
I
don't know
can't
what spirit
stand
is.
generators.
You've said it three
Boost
times.
Spirit. Oh,
Yes.
Boost Spirit.
Oh, boost.
Boost Spirit was, the template thing before, templates imploded. Somehow they became not working, not good. Um, Went from one extreme to the other. So you had this compile time parser, as static as you can make it, which, is not a bad start for your, breaking down a grammar. Um,
Well, boost spirit takes me to a page that says last edited in 2015, so that's 10 years ago.
right.
Could
Yeah.
still be good.
It's it's an archetype. My spirit library is, exactly as big as it needs to be.
Gotcha.
Combinators are cheap and easy. Spirit goes into a lot of other boost rabbit holes all at once, which every part of boost does. So that's why nobody really enjoys boost, is because it never ends. It just keeps
All right.
moving inward.
Wait. Let's. Ben was middle of explaining something, and we got sidetracked into using spirit. But I want to go back to you're using what you're using, Ben, and why? And you hate your rewriting your parser. That's what you got.
Yes, and I don't know, I've never seen Spirit, but it probably comes out to every other. Oh, but why don't
Oh,
you just use this library argument? In which case,
oh, the main
because the
difference is that
syntax is disgusting.
if you hate EBNF, you'd hate Spirit because it is uh, template, operator overloading, um, rendition of EBNF with a few symbol minimums that C++ required before whatever they call UFCS or some shit.
Well,
Now you can use emojis.
let's let Ben make his own decision on whether he wants to go use spirit or not.
I've looked at Yak, I've looked at Java CC, the Java
Who
compiler,
was
they're
Jules was
all
did a parser generator for his PhD thesis, and
Do you
I'm trying
I
to
wish he
remember.
was here.
Yeah. He's been on here before. It's been a while. I mean, he graduated and went to school and got a life and all that kind of stuff. Um, God, what's his last name? We have to go look him up. I bet you he's got that online and available.
do you use your own like custom one? Sorry, I just rejoined the meeting a little bit ago.
Oh, for
uh,
Ben doing his parser generator?
Yeah, are you using like a parser? Why don't just handwrite it? Like I feel like that's the
Wait,
easiest.
yeah, he just said that. So say it again, Ben. That, like, I hate.
I hate I hate using other parser generators because they've always got this really obnoxious syntax. I just want to write, here are the language rules, compile this into a function call. Each rule should be a function call that I have to write to go, oh, look, there's this language construct now. And I don't want to have to go through and go, oh, I can't do this because it's left-hand associative and it crashes because it's left-hand associative, or I've got ambiguous statements. I don't know how to build. No, I just want to write the EBNF, have it compile into a function call that I can write the body of that function, and get out of there. I'm sick and tired of having to go through and restructure it. Yeah. So, for example, if you want to
But what if your
restructure it,
EBNF is ambiguous?
then I crash and go, yeah, EBNF, yeah, yes, your language syntax is ambiguous.
I declare
So
violent agreement here. No more to say.
Okay, fine.
I just
violent
don't use
agreement.
EBNF.
Yeah.
I just handwrite it and be like, okay, now you have complete control, and now you don't. It's like these parser generators, they can create like loops and all sorts of like backtracking and inefficient parsing. It's just like,
No, no,
just
no,
like,
no.
No, mine's forward only. No, it continues to pass. It does the same push down autonomy that LR parsers do. It gets to a decision point. It goes, oh, look at that. I now know what this is, and it can consume the stack. It's forward only, not backtracking, blah, 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 all
Right.
that sort of stuff. Yeah. Um, and for me, one of my biggest pains is you're writing, you want to go from, oh, look, I've got a parser that builds a syntax tree to, now I don't want to build the syntax tree. I want to, build the IR on the fly. Well, one of the big things you've got to do in that reconstruction is capture your scope and pass it in. So if you've got public static class foo, then the way you normally do that is go foo and then parse all the bodies and it goes up. And the last thing you create is that class declaration. Whereas if you change your syntax so that public class foo gets called first and then that's passed into something that continually pulls in the statements as it goes, you get to keep your context
Thanks, yeah.
as you're writing, as you're going through the file. You can't do that easily. You have to go through and rip your parser to pieces because you've parsed your constructs in what you logically think versus how you actually want to parse it. If I've got a parser generator, I just change the syntax and go, no, 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 no. I actually want you to just pass me in the class name because you've already parsed it. Give it in to me. I know what it is. Go away and leave me alone. You just deal with the parser. Stop bugging me with this detail stuff. I don't want to know. And yeah, yeah.
I think there's a
I think
line
it does it.
between a difficulty of the syntax of the language where you jump from I just have a recursive descent to I need a tool. And I'm on one side, you're on the other at the moment. I certainly don't have public static final as in the language. But if I did, I'd have to start pondering, is my parser convenient enough?
Oh, it's just well, I think you still have you've made a choice in the way that you are going to parse the file.
Yeah.
And that choice is now fundamentally incompatible with its parsing style to produce an AST because you get to your enclosing scope that's some sort of name,
I
and you're tacking that on.
I fundamentally made the choice I was going to be able to do it with recursive descent. And periodically I've had to restructure how I parse things, and it was kind of a pain in the neck. But I wanted a recursive descent parser as sort of the design goal for simple. And that dictated I changed the language to match as necessary.
What about parser expression grammars?
This is Jules' thing, right? And whether or not I haven't given it a fair try, right? So it could be. So the reason recursive descent for me was tutorial. Here I'm going to show you parse a return 5, then return 3 plus 5, then return 3 plus 5 times 7, got operator precedence, then return blah, blah, blah. And I add incrementally, whereas any of the parser generators generally start with, here's this huge wad of theory you have to swallow in your head before the written grammar makes sense. Or the grammar is just don't swallow it. It's just mystery. I see the syntax. I read out how it implements is, the parser generator. It's not part of the compiler
Yeah,
tutorial. I didn't want to go there.
Oh yeah,
So
if you're writing a tutorial, yeah, I would not,
yeah,
I would not go
that's the
here
best
use it.
decision. Is
Yeah,
just evolve the grammar with the parser. So
yeah, it's what I'm doing.
yeah,
yeah, definitely. Yeah, if you've got a use case like that, that's not suited for. Here, look, I'm going to teach you how to add. Here's a calculator. No, 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 no. Here's a pen and paper. We'll teach you how
every
to add.
every possible book spends like half of its content through on parsing and
Yeah, I
what
hate
it do.
that.
Yeah,
Yeah, yeah, yeah.
that's I must over never seen a book that delves into type theory properly to explain the structure behind it, because abstract syntax tree and the skeleton of the problem is the easy stuff. I believe hards, but types are getting things hard.
Yeah,
And
you need right. Another compiler. Well, that's not fair. When I grew up, the distance between parsing and type theory was just night and day. There were two sides of the department,
mm,
and they didn't talk to each other.
yeah, yeah, yeah,
And maybe it's better these days because if I want to write a compiler, and God, everyone writes compilers. Not everyone, but obviously people here, but all kind of folks. But you need some parsing and some type theory, both at the
mm,
same time in an integrated fashion, and not
yeah,
this entire side of the department teaches a whole lot of shit, and this entire side, and they hate each other quietly.
yeah, 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 yeah. And yeah, and there are spectrums of how powerful the types are, like how do you treat them, and there is basically a spectrum where do you go, how you
Yeah,
treat them
yeah.
lightly, you guarantee some stuff with them, and there's all
No,
possible
I feel like
paths.
the first compiler class I took, we used existing languages that had parsers that built the AST for us.
Hmm.
And we used the backend that they had to do code generation from the AST. And most of the class was focused on AST to AST. Here are the peepholes. Let's find things we can do to do the cleanups.
Interesting. But that's a very narrow section
Um,
of things.
and we didn't parse and we didn't generate
You
code. It
didn't
was all
generate code.
about how do you turn
Wow. Okay.
an
All right.
existing model into a slightly better one by rolling things out or inlining or outlining.
I mean, I had to be in grad school, but somewhere between first, second year, we had to do the back end, which included all the code gen. You had to write bits. You had to do register allocation. You had to do basic block walking to do code layout.
Yeah. At no point in my entire CS degree did I do register allocation.
Mm.
Yeah.
Yeah, that's
Even a
that's
simple
something.
linear scan register allocator, like we just didn't.
Yeah. Right.
Yeah, and
Should,
optimizations lie in another category on its own. The program, the abstract interpretation of the program.
The optimizations, no, okay. It started
Okay.
with like the old school data flow stuff for me, and that would just be killing dead code around various things or hoisting bits and pieces, and then it turned into some amount of CSE and loop invariant code motion and stuff. And these are like algorithms that go all over the map. So
Are
I
there
don't
any
know.
language features that you think would really help with tree shaking?
Oh, tree shaking.
So I often find that my JavaScript stuff, where you run things through a TypeScript compiler and you get out this giant wad of JavaScript on the other side.
Right.
And it's just like, I am not calling a lot of the code that ended up in my output. Why can't the compiler guarantee that I'm not calling this
Well,
code?
the guy who ran it through the transpiler is not running an optimizer afterwards, I'll guess.
Um, and some of that is simple things. As long as you allow eval,
Yeah.
any symbol that's reachable is
Yeah,
reachable.
right. Yeah, you're doomed. Yeah, right.
So like it's pulling out a whole bunch of functions that are deeply nested inside of closures that I couldn't get to, but any reachable symbol, there's the theory that I'm about to call eval and do that thing.
Right.
So other than don't let people use eval to call a symbol that's not in context, what would you do to a language to make it easier to prove that dead code is dead?
See, this is a funny thing because for me, that's just a natural consequence of sea of nodes. It just falls out. I don't do anything for it anymore. And now, why does JavaScript have more issues here? I don't know. So maybe it's the
Well,
next
they have a
piece.
lot of eval and they have a lot of global scope.
Yeah,
Right,
I
right.
have an
But global
opinion on
scope
that.
doesn't count here. It's eval.
I think it's
Global,
both.
global scope just means I have to count for everyone else who I might call later when we get the linking in. And to get the tree shake done, you have to give me the whole program.
I
But
think like
Right, but if you
it's
give me eval, but my eval can only call symbols that exist where I am, then
yeah, I'm
anytime you
not
pull a symbol out of global scope and say it must be passed into, if I
yeah,
say you don't get access to the file system unless someone passed the file system in.
right. Right. I didn't say eval. I mean, I didn't say what's weird about having eval. If you start with the assumption no eval, then I don't understand why their tree shaking doesn't drop out all the dead shit. As soon as
I,
you have eval, then right.
I feel like part of it is also like the lack of like link time optimization essentially that doesn't happen in JavaScript, right? Because it's like, oh, okay, there might be some other script that's using these global
Why
symbols
not?
because JavaScript is dumb.
But no, but the compiler writers who are doing these things where they do transpile, like the TypeScript guys, are not dumb. Like
Yeah,
that's not an
I think they
excuse.
I mean they're working within the JavaScript model, right? So
Right.
yeah, you could like I guess hypothetically TypeScript could do this, but that would have to be like an option that you set on the compiler because if you do it by default, you're going to break so many
But why are
websites.
you breaking? If you do it by default, what broke?
Lots of JavaScript because like
Okay, same way from eval. As soon as eval comes in the picture, and maybe the answer is just that. It's always eval is always around, and you can't
well
get away from eval.
it's because you can put more than one script on the same page, right? There could be script A, script B, script C,
Yeah, right.
and these have different.
Yeah,
It's like if you're compiling one script, you can't assume that that's the only script that's going to run on the page. So you have to be a little
that
conservative with globals because you can't delete functions that might be called by other scripts on the same
okay,
page.
right. So
That's
so
that's
in
that's
the
that's forward. Just forward linking some stuff
yeah,
that you
right.
don't have loaded yet.
In any of the things that I look at, it's you've declared a global. It's you have to assume there is somebody else out there that's going to call you. And then what I just said a minute ago was I need the closed world assumption. You have to tell me the whole program. As soon as you tell me the whole program, all that dead shit should die and go away. If you're
Yeah.
going to say it's just an open world, just like Java does class for name, yeah, you can't get
Yes.
rid of the code because class for name, which is eval by another name.
But Class.forName only can load stuff that is inside the program. There wasn't another code that interpret the bytecode in
If I
the
have
global
a
system.
global, if I have a public global
Mhm.
lying around, then the assumption is if I can class for name, I have open world, somebody can find it.
Hmm.
So it can't be gotten
Oh,
rid of.
yes, yeah. There is always possibility that you can load the class that you just
Yeah.
did code.
Is there a way to hide a class from class for name?
Yeah,
Like,
yeah.
if my class is not a public class,
Yeah.
you can't class for
As soon
name
as
it,
you're,
I
yeah, I
thought.
said public global. As soon as you're not public, it's not available. So as soon as you say this guy's hidden, but if
So
you've
you would
made
say
him,
the key to tree shaking working well is limit the amount of stuff that is public global and
Mm.
therefore exposed to a class for name style thing.
yeah, I would say if you're going to go for working well, yeah, you're going to have to not generically limit, but find the cut points that you can say, this is an enclosed module. Everything else, it doesn't talk to if I don't
Yeah,
don't make the module entry points public. If I make module
yeah,
entry points public, the whole
yeah.
module is like
That's
lost.
the whole. I think that a lot of optimizations will be if you properly define a module. So what can be loaded inside a module? That would limit the stuff more.
Yeah.
That's one of the reasons why I said, okay, my language is like everything is statically linked by default unless you like call a dynamic loading function manually. And because I'm like, I don't want to encourage people to do dynamic linking because it removes so many optimization opportunities.
Yeah. But
And
the class for name is fucking useful. There are a lot of use cases for it and important ones. So it's like you're making a choice, and that's a fine choice.
Such as I leave half of my life not using Class.forName.
Right, but if I make you tag all your classes with export to be Class.forNameable.
Yeah.
Well,
Right.
I'm also thinking like the only situation like just because you like you could have something where it's like plugin or module like loadable like semantics, but where it all happens at compile time. The only time where you actually need those like dynamic lookups is if someone is like loading a plugin at runtime specifically,
Right.
because otherwise you can have like one of the things I was thinking of doing is creating
This is
like
exactly the use case, though. We're talking about people are loading at runtime.
so I was thinking that that could be accomplished like the plugins have like APIs or ABIs or whatever, and so they have these, like you treat them kind of like opaque objects that have certain APIs, and then you call those functions on
So,
the plugin.
that's Java would call that enterprise beans. There's a known fixed API and there's a bean server, and you could load this code dynamically, but it was carefully contained within the specification allowed by the enterprise bean manager, which meant that he could do sharing and some sort of efficiency hacks and whatever, but it also meant that you couldn't do a lot of things that you really badly wanted to do. And so there's real limitations to what a bean was useful
Ooh.
for. Class.forName, it's out there.
And so what's the main use of Class.forName though for like dynamically loading stuff?
Um, some of it is lazy setup. When I start my server, I do have these plugins. Like I'm looking at my IntelliJ, he's got a plugin for Kotlin and a plugin for this and a plugin for that and whatever. Um, but IntelliJ himself is not linked against all possible plugins. And I don't load all possible plugins into IntelliJ. But at some time at startup, I get some list of 5 or 10 plugins. And that's just from IntelliJ's point of view, Class.forName, some new code that changes how the edit works and changes how his color scheming works and how his search works and how the lookup this works and that and whatever he's going to do. So things like that show up in a lot of places. As soon as I have some interestingly large system and I'm selling it to a client and the client has customization, he's going to Class.forName his customization in. I guess
I'm
that's
I'm wondering like, isn't it possible to do the same thing with like generic type erasure, like standard function style? Okay, I have a function callback that could be any, type erased thing.
it's what am I going to allow you to override or see or edit on this new piece of code. And if I can hide it from you and keep a sharp interface, narrow interface, then I can load anything I want, and you're limited to what you can do through the interface. And then I can optimize on my side because you can't do shit to me. And if I make that too tight, then I lose out on all kinds of cool things like the editor and IntelliJ understanding the difference between how to color highlight boost versus C++ versus Kotlin versus shell scripts, right?
I,
And
gue-
then,
I guess it's just like where you have the opportunity to have the language help you with these plugins, but otherwise it's kind of
that is a
semantic.
thing. Now, having said that, every web server on the planet sucks in code. Call it JavaScript instead of Java, but it's Class.forName, same thing. And they're using it to change how the web page is displayed and edits and what interactivity is on it and all that kind of stuff. So essentially, every JavaScript web server on the planet is Class.forNaming. Um, there are a lot of these systems that run around that just say, "Hey, I can add something in here." Now, why does tree shaking not work? Because somebody, I'm guessing that the problem here is that the guys writing their code want to reach for public static for convenience for them, but then they want to say it wasn't really public, not in the public sense. It was only company public or module public or my workspace public. And there's not another layering that's convenient for them to deal with, so they just grab public. Now suddenly it's worldwide public and Class.forName can go find it, and then suddenly you can't tree shake it out.
Well, so like the thing I was thinking of, there's this JavaScript library for building charts.
Right.
So all of the different chart type chart builder classes are public classes because of course they are.
Right.
And I've got a website that's using 2 of the 200 kinds of charts that this library
Yeah.
supports.
Right. Yes. Okay. Right.
The
Right.
other 998 are public and class for nameable and are technically reachable.
But you're
And
not
I
calling.
kind of just want to be like, no, no, I promise from this library, I only want these two.
So you kind of want to say, I have my code and I'm bringing this other library, so all these public things, and I want to wrap these two together in a box and say, this is a closed world with exports from my code, not from anywhere else. In
Right.
this closed world, tree shape. And you'll say, oh, I call A class and B chart and
Right.
C
I
chart
want to
and
say, I
of
have
course.
imported this thing,
Yeah. 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 Yeah.
and I'm going to export only the two that I care about.
Right.
Like, I want to
Yeah.
make a closure that
Yeah.
closes over the library that I've imported and
Right.
exports two symbols. And
Right.
now everything outside of that closure can only reach the two symbols because I've
And
made my
need to kill.
firewall wrapper
Right.
around the thing I imported.
And then obnoxiously, Cliff comes along and wants the same charting package, but wants three other different charts that are not yours. Oh, I'll also second this giant chart package. Is there any sharing that can be done there? Maybe. We can go to that. That's a different optimization problem. But yeah, I think that's the right answer. Some way to, at a language level, conveniently to
Yeah.
close over the
To
imported.
firewall this thing and say, I would like to import this into my context, but I don't want to import it globally.
Yeah.
Which, for
Yeah.
example, Python is not very good at. In
Really?
Python, when you say import,
Yeah.
your import gets stuck in the modules dict.
And then it's available for everybody.
Right. All modules are in some sense global because
Created
that's how it
equal.
ensures you don't import the same module 37 times.
Yeah.
Is
All
it
modules
says,
are equal.
is the
Right.
module in the modules dict? If it
Yeah.
is, great.
Cameron would say
No
XD
op.
was covering this case. And I'm not there, although I could be there. I mean, I approve. I think it's the right answer. I don't have a solution sitting in my head.
I mean, I think AA is in a relatively good place to
No, AA
do
could do that.
stuff like that just because it's the
It doesn't,
nature of
right?
its imports are you import a symbol.
Yeah, it doesn't, right? It doesn't have any public imports, not in that sense.
There is no global module zone. Actually, that's an interesting question. Let's say you're in AA
Hmm.
and you have 30 different functions that all want to import the same module.
If they don't cooperate, then they'll import it individually, and then you want to say, common sub-expression elimination cleans it out. But that's my
Will
answer.
it?
It's a compiler optimization says, oh, these are all duplicates, line them up and fold them. But if they don't cooperate, so you could
So
imagine
most
some.
of what's in most packages is a static because it's like, here's the name of a function. That function is a value. The function never changes.
AA won't. AA just has the nesting, so there's no global scope, or there is a global scope, but it's not by default anything you import into or from or whatever. You have to.
Right. But my question is if I've imported the same function 37
Yeah,
times
yeah. You import
and
the
there's
original.
no like state in that function, it's not a closure over something. It's just that function 37
Yeah,
times.
yeah.
Will it notice that that's a constant and let constant propagation remove it?
Um, Not without more work because you have to go. You have to do outlining as an optimization. So the easy answer is you go ahead and do the global module space thing, which you could define one in AA, but it doesn't come baked in. And then say, okay, I am importing this guy, but also tell other people that I imported him. And if somebody else also wanted it, we'll agree that we're sharing. And so you could, and in fact, you could nest those, but you have to cooperate and say, I am grabbing this dude, and also I want to share with anyone else who grabs the same guy.
So
The
better
the
tree shaking, but possibly at the cost of duplication because you didn't realize two things were the same
Yeah,
constant.
if two guys agree, both suck in the same thing, and they don't agree, or they don't tell each other about it, then there's no obvious hook. The only thing out of that one, whatever the way out of that one is to do the outlining optimization, which would pick up all kinds of other things. It might entirely be very useful in these giant, large systems that are just people just glom shit in more and more and more and more and more. Almost surely an outlining pass would be the right answer.
Yeah, I mean, to some extent, you can help that with a just tradition in your community of
Yeah,
do all of your imports in main and pass dependencies down.
yeah. Well, okay. I would say dependencies would be, yeah, okay. Right.
Right.
Somewhere in
I
main,
import the
somewhere early
charting
on you
library in
said,
main, and I
yep,
pass the charting library
yep,
into my functions that need the charting
right,
library.
right. And then pass it along. Yeah, right.
I import file system in main, and then I pass the file system object
And you
down.
pass the file system along. Yeah, yeah. Yeah. But you've agreed up front to say, I am going to allow or expect or hope for sharing. And for state-free things, that's all like it's just code. Those are all constants. It's
Right.
used
There
for
becomes a
sharing.
difference between saying A equals import my module and sys.a equals import my module.
Yeah, I would have a different name. One would be import, right? Import for me. I'm only putting sys in as the free name. So it'd be sys.import for me, and then there's sys.global import or something like that, where you expect sharing on the globals and you don't on the nons. Yeah. Yeah. Um, yeah, Jim, I don't know. Yeah, okay. The chat's busy too.
What is
Dot
DOT in that
parsers.
context?
I don't know what a dot parser is either. I would have to go ask naming things. But left recursive versus right, I carefully define grammar. They're talking about parsers again. I did simple grammar, an AA grammar that you didn't have to do left recursive. Didn't do left recursive parsing. That's generally very simple to arrange for, not to deal with it. All
Yeah,
right.
it's just Spirit doesn't handle left recursive.
Yeah, I would look up Jules, and I gotta go find his name. He's on Coffee Club, and he had the parser generator. I'm pretty certain he dealt with left recursive. I mean, I don't know if you're looking for another parser generator, but that was his modern PhD thesis. So he's done a modern version of parser generators, and he might have a better answer for you.
No, I've got my parser generator. It does exactly what I want it to do now. I
Well, then
just
you're done.
write the
Okay, fine.
syntax how I want. It's absolutely fucking fantastic. Oh, excuse my French.
Done.
But yes,
Okay.
it's really, really good. I'm so, so happy with it.
Well, then you should clean it up and put it out for the rest of the world to use.
Oh, clean it up. I think it's only like 30 lines. Sure.
Oh no. Oh wow. Okay. You must be pulling in something else then on top of the 30 lines.
Oh yeah, you're pulling your parser definition, and then you pass the parser definition to a set of rules, and then the set of rules becomes your um, whatever your data table, and then you run through your data table. So it's just a while loop, a couple of while loops here, there, and everywhere. But the actual body execution part is only 30 odd lines as it just spins, just chewing up the tokens supplied by the tokenizer.
Okay. Okay. Like I said, that sounds interestingly small and easy to use, so might be worthwhile for other people to look at.
Yeah, I got to get it up on something that a Git hosting service somewhere.
Right, you got to put it somewhere. And that's what I was
Yeah.
really laughing at was that you got to document it, you got to fix the bug people come to you, and you got to go put it up before it can be visible, and then no one actually looks at it, and it's all that kind of stuff. It's like, oh my God.
Yeah, no, I, I'm happy with it. I'm
All right,
satisfied.
I'm gonna claim, done for the moment. I've got a whole lot of weird things going on this weekend, so we'll see what I can
So
get
take it
done with.
daylight savings ended.
That was last weekend.
Yep.
Yes, it has ended or begun, whichever way you want to counter it. Some hour was lost to somebody somewhere last weekend for no good reason.
It'll come back in 6 months. Don't worry.
Come back in 6 months. That's right. And the weather's getting warmer. I have a short sleeve shirt on. It's not quite t-shirt weather yet, but I might get my coffee club shirt on maybe next time. We'll see.
That was my favorite bug I ever saw at Google, was one that reared its face only during the second 2 a.m. of a day.
The second 2 a.m. for daylight
Right.
savings
It
time.
would jump back, and all of a sudden you had these timestamps that were in the future,
Yeah.
and things that were using UTC1, time kept monotonically increasing, and things that were using Pacific time, time jumped back an hour.
Yes. Uh-huh. Yeah, a lot of
And
time bugs floating around. The whole Linux, Unix, epoch timing
what
thing
amazed me
saved a
was
lot
when
of
I
things.
went to fix it, And I was like, oh my God, how do I even know when this happened? And it turns out that the time zone object in Python has a bit that says, is this the second occurrence of this hour? And I was able to just check that bit and behave differently.
Oh God. Wow.
And I was just
Okay.
like, I did not realize that the Python time zone object had a bit for, is this the first occurrence of the hour or the second occurrence of the hour?
Wow. That is like way, way too complicated and too much overhead to match. I
You
mean,
feel like your timestamp shouldn't require a bit for whether it's the first or second
uh-huh.
occurrence of that hour?
Uh-huh. Exactly. Exactly. Yes.
But if you're trying to convert stuff from UTC-1 to Pacific time, that's a
Fine.
bit that exists. Otherwise, you have an ambiguous hour.
I
Yes.
mean, there's Pacific Standard Time and Pacific Daylight Time. Why don't you just pick one?
No, not necessarily. You get the option. There was I mean, I did this whole fintech thing, and the exchanges all just recorded since the 70s would just record numbers down that were some amount of time relative to their current time zone. And then time, daily savings time, and all this kind of shit would bounce around. And so if you wanted to know historically when a transaction happened, it was a giant mess to try to sort out uh, before and after and around time zones and
What is it?
different
What is
people in
it?
different spaces.
TAI or TIA time? What's the uh TAI, International Atomic Time?
Yeah,
Uh,
the
it is
exchanges in the 70s and 80s were not using that.
Yeah, it is as uniform as possible, regardless of variations of the rotation of the Earth.
Yes.
Yes, it is the
The-
number of cesium seconds since 1970.
Oh really? Yeah, okay.
No leap seconds, no leap days,
Yeah,
no, we don't care an earthquake happened and changed the rotation of the Earth or a comet passed near the moon. Like, decays of a cesium atom. It is the
gotcha.
cesium second since 1970.
Sounds
Done.
reasonable. Yes.
yeah, that should be like all computers should use that as the like storage format
Yeah.
of times, and then everything
You
else is just
just
display
All
format.
computers should
just
use
named
cesium atoms
you
inside
should
them.
just name the solution and the problem at the same time. All computers should.
Oh, they should
The
use
problem
it.
is they don't. And that's the problems that people deal with, like what Aaron was just doing. All right. I'm gonna go have lunch. Y'all have a great weekend. We'll try this again next week. All right.
Yeah.
Bye-bye.
Yeah, bye-bye.
Weekends, a concept that does not exist in atomic time.